Okay, so we'll have our test Wednesday. I have posted the review, so you can find it. It's a jar file, so it's like the ones on your jump drive. And you'll have to check the review. I don't think I'm doing anything from sections 4 and 5 in the, I think I do that on the final. So I think it's just chapters 5 and 6. And chapter 6 as far as we get. Yeah, those are not on this test. For some reason, so I just decided I wasn't. I'll let you know. I think I put 1 or 2 on the final. Yeah, your cheat sheets. So if you've got cheat sheets from the other tests, you can just bring all those in. So we need to cover section 3 today because that's on the test. And I'll still, you'll probably say, you're crazy, but we will have 25 minutes of class before the test, like we normally do, even though it's the last day of class. Nobody accused me of not getting your money's worth. There's something else I was going to tell you. I can't remember what that was.
Did you see the election results in Austria?
I saw that the left wing beat the center, the right wing, which that's at least one case where. That guy was, yes, yeah, he was way off to the other end. Yeah, it was. I mean, it was that close. I mean, I don't know how much he didn't win. He didn't lose by a huge amount. And then there was the Italian vote on some constitutional question, which I don't really quite understand. But I think what it is their government is such that they can't ever get anything done because everything grinds to a halt. And it was supposed to be a mechanism for improving, but it gave more power to the executive branch, which they apparently didn't like. Okay, so chapter 6, section 3, the name is rational numbers. It's basically learning about fractions, which you've done before, but that's typically not a great skill for people, so I think it's worth going through. So basically what we're going to do is learn how to simplify fractions, how to add fractions, how to multiply fractions, and how to change fractions to decimal, which is pretty easy if you have a calculator, and how to change decimals to fractions, which if you don't have a calculator, it's not super hard. So as we've seen before, a rational number is a number which is a quotient of 2 integers without the denominator being 0, because if it's 0, then it's undefined. So we think of rational numbers, they're fractions. So I'm not going to give you time to write anything because we've already done that before. So there's this interesting fundamental property of rational numbers. We had this fundamental theorem of arithmetic, which I'm trying to remember what the heck that was. I think it was that basically something to do with factoring, not factors, but factor or multiples. That's a while ago. So what it says is if you have 3 integers, a, b, and k, with b not equal to 0 or k not equal to 0, and again you can't let those be 0 because you have an undefined quantity, then the following is true. So if you have a rational number a divided by c, and you multiply the numerator and the denominator by the same number, the resulting expression is the same as the original expression. So it's saying that, well, basically what it's saying is that, as an example, let's say you have the rational number a half. And if you multiply the numerator and the denominator by any integer, So let's say we multiply it by 3. So in this terminology, A would be 1, B would be 2. Therefore, A over B is a rational number. C is 3. The resulting number, which is still the left-hand side, so this is not the right-hand side of the equation, this is the left-hand side, would be 3 divided by 6. So that's the left-hand side, this part. Once you multiply it out, is equal to the original rational number. So that's the right-hand side of the definition. It's kind of like, you have the property of addition where if you have an equality and you add the same thing to both sides of the equation, the equality still applies. So, if we have something like x plus 4 is equal to 2, if we add the same number to both sides, so we have x plus 6 is equal to 4, what we're saying is that these two, even though the equations look differently, they're equivalent to each other. Another way of thinking is if you solve for x, you get the same number. You get -2. So these two expressions are equivalent, and what it's saying here is that 3/6 is exactly the same as 1/2, even though the numbers are different. Another way of thinking about it is if you have a rational number that you can simplify, the simplified answer is the same as the original answer. It just has different numbers, but it means the same thing. If you had 6 things and you say, 3 out of 6 of those is the same proportion, so 3 out of 6 is the same proportion as 1 out of 2. So what this is trying to remind me is kind of going the other direction. If you have, say you start with a fraction or a rational number that's in its simplest form, and I take that and I multiply both the numerator and the denominator by 2, which is what I'm doing here, the resulting rational number, 4 divided by 14, that's another way of writing 2 over 7. Or you could say 2 over 7 is the same as 4 over 14. You could do the same thing with a different number. So if I started with the same simplified rational number and I multiplied it by 4 divided by 4, I have 8 divided by 28. So therefore, 2/7 is the same as 4/14 is the same as 8/28. Okay. Now, one thing we want to know is, a lot of times you want to know whether two rational numbers are equivalent to each other. One way to think about that is if you simplify both sides to the simplest form and they're equal to each other, that is one way of showing that somebody locked out. Did they get locked? Well, I guess couldn't get locked out. Must just leaned against it. So, the question, this one you probably don't need this rule, but if I said is 3/6 equal to 4/8? Well, one way of doing it would be to simplify these to their simplest form, and that means if there's any common factor between the numerator and the denominator, you can divide each one of them by that common factor. So each one of these is divisible by 3. So if I divide both of those by 3, I'll get 1 divided by 2. And if I see here the common factor is 4, and so I could simplify, if I divide this by 4 and I divide that by 4, I get 1/2, and so we know they're equivalent. A lot of times they're not as easy to simplify, and so if you wanted to be able to quickly evaluate whether two fractions or two rational numbers are equivalent to each other, what you do is you just cross-multiply and then compare the resulting products. So instead of simplifying the fraction, what I would do is I would cross-multiply, which is allowed because they're just pure ratios. So I take 3 times 8 is equal to, the question mark, is equal to 4 times 6. And then you plug it into your calculator, and you get 24 is equal to 24. And so that's another way of checking it without having to simplify the fractions, is to cross multiply, compare the results. So, for example, let's pick another fraction that maybe it wasn't, 2/7, and I'm going to just do a little calculation here. So if I saw this, I couldn't just look at this and say it's 2/7, or if it isn't 2/7, I don't know the answer. Well, I know the answer because I made it up, but you don't know. You look at that and you say, well, maybe it is, maybe it isn't. And I could, try to find common factors and simplify this, but that would take time that I don't really need to do. So I would take, what I would do is I would cross multiply and then look at the answers. So 2 times 357 is 714, and 7 times 101 is 707. Well, they're not equal. We know those are obviously not equal because they're just numbers. They're not rational numbers. So the original thing is not equal. So what I did to do this problem is I multiplied this times 51. I multiplied 2 times 51, which is 102. So I changed it slightly so I knew that I wouldn't get the same answer. This is actually, if you multiply this by 51, you get 357. If you multiply this, so it turns out that if I had this instead, 102 over 357, and I cross multiply it, and the question is that equality true? Are they the same result? Then I would take 2 times 357. Is that equal to, question mark, 7 times 102? And I plug those in my calculator, and I get 714. And on the other side, 7 times 102 is 714. So yes. So since those are equal, these are equal. So if I put something like that on a test, I'd basically give you a rational, I'd give you the equality and ask you, is this equality true? And instead of simplifying this one down, you just cross multiply and compare the numbers. And if they are equal to each other, then you would say, yes, they are equivalent. If they're not equal, if the product is not equal to each other, then they're not equivalent. Okay, adding and subtracting rational numbers. So this is kind of different than what you might remember. So before we read this, let's go back and think about what we might do based on our previous knowledge. At least I think that's. So let's say you have 3/4 plus 1/6. So what you might remember is you would find a common denominator, because you can't add rational numbers unless they have the same denominator. So what you might do is you might say, well, what's my least common multiple of these two numbers? So we could use the procedure that we learned. We don't really need to use it, hopefully, but let's just use the procedure. To find the least common multiple, we'll use the second technique. So we write the two numbers down, and we divide them by a common factor, which would be 2. So the result of that would be 2 and 3. And then you say, do I have a common factor between these two? The answer would be no. So that would mean I'm done. And so my least common multiple would be equal to 2 times 2 times 3, which is 12. Okay, so that's my least common multiple. So what I want to do is I want to rewrite these as 12ths. So I would take the first rational number, and to get twelfths, I would have to multiply 4 by 3 to get 12. So I'd multiply both the numerator and the denominator by 3. And for the second part, to get 12 in the denominator, I have to multiply both the numerator and the denominator by 2. And when I multiply these together, you multiply the numerators together, you get 9 and 12, so you get 9 twelfths. And here we'd have 2 twelfths. And then now that you have a common denominator, you can add the 2. So this is the same as 9 plus 2 over 12, and that's 11 twelfths. Okay, so that's the way you might remember doing it. So they're showing, they're showing a different, and you wouldn't necessarily have to go through this long. You'd probably say, well, 4 times 2 is 8, times 3 is 12, so I need to multiply them both by 3. 6 times 2 is 12. Hey, that's the same number. And that should be a multiplication sign there, not a plus sign. So, you could probably figure out what the common denominator would be. But they show this in the book. They say that A divided by B plus C divided by D is A times D plus B times C divided by B times D. So let's try their approach and discuss why they might have done that. So let's use the same two numbers, 3/4 plus 1/6. So what we do is we take A times D, so we'll take 3 times 6 plus B times C. B is 4, C is 1, and we divide by B, which is the denominators, so we multiply the denominators together. And so we get 18 plus 4 divided by 24. 3 times 6 is 18, 4 times 1 is 4. We add those together, we get 22 24ths. Which is not the same exact, well, it doesn't look the same as 11 twelfths, but we can simplify it because these are both even numbers, so we know that we can divide both by 2, and so we divide them both by 2, and we get the same answer. So why do they do that? They don't talk in the book. They don't talk about common denominators. I think it's because the reality is this is an easier approach. All I'm doing is multiplying numbers together, and then I'm simplifying. I'm not having to think about least common multiples, even though they did teach us that in the last chapter. We didn't have to worry about least common multiples. We didn't have to go through this process of multiplying the numerator and the denominator by the same numbers. So this, if I give you a problem like this on the test, do it this way, not this way. Just write the formula down. You will have to, you might, most likely will have to simplify it at the end. And what we're doing here, in this case, is we're looking for the greatest common factor between the numerator and the denominator. And then you divide each of those by the greatest common factor, and then you'll get the answer. But we're going to show you how I'm going to show you how you can simplify without using the greatest common factor. So I teach you it and then I tell you not to use it. That's kind of partially because of the way they introduce this here. So let me just give you a problem to work on. Let me see if I have one already or if I need to make one up. Oh, there we go. Okay. Well, this one's easy, right? Because it's already got the same denominator. So if they're the same denominator, you don't have to, you just add the numerators together. We don't have to use the long way. We'd only use the long way here if they're different. So let's do this one, but let's put a plus sign on it. So in this case, we don't have the same denominator. So remember what they said was A divided by B plus C divided by D is AD plus BC divided by BD. So go ahead and plug that in, see what you get. And all it's a matter of doing is just looking there and putting them into your formula. So for you guys online, if you can put an answer in, so I know you're following along. Also, I have the exam review posted as well. So if anybody wants to look at that. So for you guys online, there's the answer. You just need to write it in your chat box so I know you're paying attention. Is that what anybody got? Everybody got 37 over 24? The least common multiple of these two is actually 24. So we didn't have, and 37 is a prime number. So there's no way that we could simplify that. If you didn't know 37 wasn't a prime number, you can't divide it by 2. You can't divide it by 3 because 3 plus 7 is 10, which is not divisible by 3. If you can't divide it by 2, you can't divide it by any other odd and even number. You can't divide it by 5 because it doesn't end with a 0 or a 5. The only number that 7, but that's not going to work. 7 times 5 is 35, so it's a prime number. So there is no simplification. So let's do the same problem, but let's subtract it. So if you took 2/3 minus 7/8. So the case of subtraction, you have A times, I don't need to put the parentheses. You take A times D minus B times C divided by B times D. So we've already actually got all the numbers here. You just have to subtract. 16 minus 21 divided by 24. All I've done is just go back here and change the sign. So you get negative 5/24, which again is that's as simplified as you can get because you can't divide 24 by 5. Okay, so give that one a try. You use your calculator to find out those. Did anybody see the Saturday Night Live Trump sketch? So it was basically, it was sad. No, just kidding. So this is interesting. Actually, this is kind of interesting. So basically, it's Trump with his cell phone twittering stuff, and there's these two guys from the CIA or some, and they're saying, we'd like to give you an intelligence briefing. Can't you put your cell phone down for just a second to pay attention? And you can only, like 10 seconds go by and he's already sent out a tweet. I guess the joke was that he retweets stuff that he has no idea whether it's true or not. So I don't do Twitter, so I don't. What? Make a Twitter? Yeah. Follow Trump. Yeah.
So many, like, 4 in the morning, you know that he woke up to crap in his golden toilet.
Yeah, so they're making fun of him retweeting stuff as well as not having an attention span longer than about 10 seconds. Yeah. So then, yeah, so that was kind of the thing, and then, of course, Donald Trump tweeted about being made fun of for tweeting so much, just to reinforce the preconceived notions about Trumpo. The crazy thing is that why, like, you know, all of his surrogates, whatever that means, yes men and women, you know, whatever he does, they have some excuse for him doing it, which if it was a Democrat the other way around, they would be so blasting them. It's just the double standard as far as, what's that? We would do. Oh, yeah. Okay. It is to a degree, but it's, yeah, they go take it to a different level. Okay, so that's what we do. So we got 19 times 12 minus 15 times 7. Oops, I did something wrong there. Let's see, 19 times 12 minus 15 times 7. So the numerator is 123, and the denominator is 15 times 12, which is 180. So that would be your unsimplified version, but that's not, you're not finished until you see if you can simplify the fraction. And because you should, because you have a common factor here. You know, if you have a common factor between the denominators, there should be some way of simplifying it. So what you do is, it's kind of like when you prime factorization a number. You start with the lowest prime number and see if the denominator and the numerator and denominator are divisible by the same prime number. You don't want to try a large number. Just start with nice small numbers, because then you won't do any more work than you need to do. And so I look at this, I cannot divide by 2 because the numerator is odd. So then I go to 3 and I use the trick. I add my numbers together. 1 plus 2 plus 3 is 6. So I can divide 123 by 3. And I can also divide 180 by 3, because 1 plus 8 is 9, which is divisible by 3. So let's go ahead and divide them by 3. So 123 divided by 3 is 41. And 180 divided by 3 is 60. So we get that. Okay, now we see, is there any common factor between those two? Again, once we've ruled 2 out, it's not going to magically appear. So we know 2 is not going to work. So we go 3, 4 plus 1 is 5, which is not divisible by 3. So 3 is not going to work. 5 is not going to work. 7 is not going to work. And so we're done. So we only had to go one level as far as simplification. But what we did is we divided by a common factor. Okay, so that's adding and subtracting rational numbers. Do not find a common denominator, because they didn't put that in the book. Use the formula, simplify the answer. Okay, multiplying rational numbers piece of cake. If you multiply two rational numbers together, the resulting number is the resulting product is the product of the numerators divided by the product of the denominators. So here we'll do a few examples. So here we have 3/4 times 9/5. So we multiply the numerators together and we multiply the denominators together. Can we simplify this? Well, not by 2. I can divide this by 3, but not this. So if I can't divide it by 5, I can't divide it by 7. So I don't have. That's actually simplified as it gets. Okay, next one. Negative 2/4 times 3/9. Now I'm not simplifying it. You might recognize this is a half and this is a third, but we're not going to worry about it. We're just going to use the formula. So when you multiply two numbers together, two rational numbers together, you multiply the numerators together and the denominators together. Now the negative sign, I could go in the numerator or the denominator, just have to choose one or the other. So that's my answer. Now can I simplify this? So we look for common factors, but we're going to start, I'm just going to ask you to start with the lowest prime number. So you might say, oh, they're divisible by 6, and that's true, but let's do them one step at a time. In this case, adds a little bit extra work, but in other cases it's easier just to start at 2 and keep going up. So these are both even, so I can divide by 2. So 6 divided by 2 is 3. And 36 divided by 2 is 18. And then I try again. So they're both not even, so I can't use 2 to simplify. But this one is divisible by 3 because 1 plus 8 is 9, which is divisible by 3. So I divide both of them by 3, and I'll get negative 1/6. And there's your answer. So on the test or whenever, when you do the simplification, if you can show me what you're dividing by, so I know you know what you're doing. Okay. Dividing by rational numbers. Well, as we saw in a previous section, dividing is like multiplying by, I think we talked about that. If not, we're doing it now. Let me put this on one page so you can see it better. So if you have a rational number and you divide by another rational number, what you do is instead of dividing by this number, you multiply by the reciprocal. And the reciprocal of a rational number is you just switch the numerator and the denominator. And then it just becomes a multiplication problem, which is, we already know how to do that. You multiply the numerators together and multiply the denominators together. So I'm going to make one up here. So let's say 2/3 divided by 3/12, which actually is a fourth, but we'll ignore that for right now. So what we do is we rewrite the division problem as a multiplication problem by taking the reciprocal, which is easy with a rational number because we have a clearly defined numerator and a clearly defined denominator. So once we do that, then we just use the rules for multiplication. So you get 24 divided by 9. And then we simplify it. So we look for a common prime number. And because they're not both even, we go to the next prime number, which is 3. And we can divide both of these by 3. So 24 divided by 3 is 8. 9 divided by 3 is 3. And that's our final answer after we simplified it. Now this original rational number, you can actually show it in a slightly different way, is like that. So it's a rational number, and it's not really a rational number anymore because rational numbers are integers divided by integers. Maybe that's why they do it this way. But a lot of times you'll see a problem cast in this way in more high-level mathematics if you deal with fractions. So you do the same thing, except you keep the numerator the same, and whatever the denominator is, you take the reciprocal of it and remove the dividing bar. So it comes to the same result because when you have a fraction divided by a fraction, sometimes, it gets confusing. Which ones do I multiply together? Which ones do I divide out? And it's always so much easier if you just think about all I have to do is take the reciprocal of the denominator of the big division and multiply it by the numerator of the big division. So you get the same answer. You get 8/3. Okay, so let's look at another problem. So 15/16 divided by 30/18. So you take the first term, and instead of dividing by the second term, you divide by the reciprocal. So then you multiply the numerators together, 15 times 18, which is 270, divided by 16 times 30, which is 480. Now, if you remember back, if you ever took MTE, what they would expect you to do there is you can move the numerator and the denominator around, and you can simplify. So 15/16 times 18, 30, 30. If I move the 30s over here, what that does is it makes me easily see that I can reduce the first fraction down to a half, because 15 is half of 30. And here you might divide by 2, so you get 9/8, and then you would get the answer, which is 9/16. So that's the MTE way of doing it. They don't really talk about that in this class. So you just multiply it out, and then you simplify it, which ultimately is going to get you back to the same answer. So why is, you get these big fractions, and that's one of the reasons they show this way in the MTE classes. So when you simplify it down, you can do it in your head instead of having to use a calculator. And so in this case, if you use the calculator, what you would probably do is make this a decimal, and if I make this in a decimal, I'll get the same answer. But a lot of times you don't want to end up with decimal as your answer. You want a fraction in the simplified form. So the question, what you would normally think of doing is what is the least, greatest common factor between these two? But the process of getting the greatest common factor we can do essentially by just following the same procedure. Is we can divide by the same prime numbers. Now, in this case, you might say, well, can't I just divide by 10 for both cases? And the answer would probably be yes, because it's so obvious that they're both divisible by 10. So you can do that. If they end with zeros, just remove the zeros. I'm not going to make it any harder than it needs to be. So you get 27/48, and then you look for another. Go back to 2 again. Once I've used the big, hundreds or tens, I can. So I can't divide them both by 2 because they're both not even. So then I go to 3. 2 plus 7 is 9, which is divisible by 3, and 4 plus 8 is 12, which is divisible by 3. So I'm going to divide both by 3. I guess what I did here was divide by 10. So I get 27 divided by 3 is 9. 48 divided by 3 is 16, and now I have no common factor. I can't divide this by 2. I can't divide this by 3. So I'm done, and I get the answer. So it's the only thing that this makes sense is if you didn't have a calculator to multiply these two numbers together. You'd just have to do that by long multiplication, which would be a pain. But this is the way that I want you to do it. Use the fact that the dividing by a fraction is the same as multiplying by the reciprocal of the denominator, and then multiply it out and then simplify it to get your answer. So here's another one. So we take -9/16 multiply by the reciprocal of the quotient, of the denominator in the quotient. Then we multiply, use the multiplication rule. The negatives, the double negatives say it becomes positive. So it's going to be positive, and we get 72 divided by 48. And then we simplify it. So in this case, we can't divide by 10, so we're going to start with 2. So I'm going to divide by 2. You get 36 divided by 24. Divide by 2 again because they're still even. Divide by 2 again because they're still even. And then divide by 3 because they're not even anymore, but they're both divisible by 3. So we get 3 halves. So the answer is 3 halves. We could have gone in one, if we recognize both of these, the greatest common factor is 12. 36 divided by 12 is 3. 24 divided by 12 is 2. But this way, we're just dividing by small numbers, which a lot of times you can do in your head once you get used to it. So don't plug this into your calculator and then just say, change it back into a fraction. I want to see the intermediate steps. If you have one of these calculators, what happens is you'd actually get 1.5, and then I think you can convert 1.5 into a fraction. I think that's the way it works. Let's try that. So 72 over 48 is 1.5. And let's see, how does this work? Math, fraction, enter, 3 halves. Yeah. So that's a cheat way. Okay, this is a little harder just because it uses order of operation. So if you have 1/3 divided by 7 halves, again, we do everything inside of a parenthesis first. Once we get a rational number from this operation, then we can add it. But first we have to do what's inside the parenthesis first. Even if the parenthesis wasn't here, we'd still do this first. So you take 1/3, instead of dividing by 7 halves, you multiply by 2/7. So in the multiplication, we get 2 divided by 21. And that's the simplest form we have, 2 21sts. To do the second part, we use the rule for adding fractions, which says that this is the same as this times that plus that times that. Divided by the sum of the two, now the product of the two. So that part we'll do with a calculator. 2 times 6 plus 5 times 21. That's 111 divided by 12, not 12. Six times 21. Need another parenthesis there, don't I? So 126. So now we think, can we simplify that? Can we simplify it? Let's ask that for an online question, see if you're paying attention. The answer is either yes or no. It's a yes or no question. So can you simplify that? What do you guys think here? What would you do? What is one common factor? What number? Is it 2? Is it 3? Yeah. Why is it? Well, 1 plus 1 plus 1 is 3. And 1 plus 2 plus 6 is 9. Each of those is divisible by 3. So the answer was yes, you can simplify it. So once we know we can divide it, that part we're going to have to do with our calculator. Or we're going to do it with our calculator. So we get 37 over 42. And then we think about that one. Well, we already couldn't divide by 2, so that's already out of it. 3, we can't divide by 3 because 3 plus 7 is 10, which is not divisible by 3. Can't divide by 5. So that's the end. Another reason is 37 is a prime number if you didn't know that, but that's the final answer. Okay, continuing on. So how do you convert mixed numbers to a fraction? It's kind of interesting, you know, mixed numbers you learn a lot about. And if you take calculus, for me, we never use mixed numbers. We always use improper fractions. But an improper fraction is where you have just a plain rational number, and it's where the numerator is greater than the denominator. So a mixed number results from a number where the numerator has a higher value than the denominator. So there's a couple of ways you could do this. You could think, well, this 3 7/8 is the same as 3 plus 7/8. And then you could say, well, if I can convert this to a fraction with a denominator of 8, then I could add the two fractions together. So I would take 3, and remember 3 is 3 divided by 1. And I would multiply the numerator and denominator by 8. So I'm actually finding a common denominator here, which is something I told you not to do, so that's not the way that we want to do it ultimately. So you'd end up with 24/8. So 3 and 24/8 are the same thing. You can, if you take 24 divided by 8, you get 3. So we haven't changed anything. And then we add the two together. So we'd have 31/8. So that's the mixed number. That's the improper fraction. Another way you can think about it is, what I would do is, if this is 3 divided by 1 plus 7 divided by 8, the way the book shows is you use cross multiply. You'd have 3 times 8 plus 1 times 7. So I'm taking this times that. I'm making this into a rational number. And once I have two rational numbers, then I can use the formula. And so I get 24 plus 7 divided by 8, which would be 31/8. So that's the second way of doing it. So first way, break it up to two parts, find a common denominator, add it here, adding two rational numbers using the formula in the book. The way that I do it is the answer is going to be this times that plus that. So you take the whole part of the answer and you multiply it by the denominator of the fraction, and then you add the numerator of the fraction part, and you divide by 3 times 8. It's the same as this, except I'm simplifying it. So I would just take, what I would do is take 8 times 3 plus 7. 8 times 3 is 24, 24 plus 7 is 31, so I get 31/8. So that's how you convert a mixed number to a fraction or to a rational number. Which one do I want you to use? Either one of these here, because these are pretty much the same thing, except I just left the 1 out of there. And except I did something wrong there, didn't I? Divide by 8. Okay, so that should be pretty easy. Now, how do you convert a improper fraction to a mixed number? What you do is you do long division, and except it's the other way around. Let's try it again. Is that right? Yeah. No, that's right. This is right. 19 divided by 3. No, this way. It is this way. And so you ask the question, how many times can 3 go into 19? And the answer is, well, it doesn't go equally into 19, but the closest number smaller than the that goes evenly into some number less than 19 is 18. 6 times 8 is 18. 6 times 3 is 18. So you do that, you subtract it, you get a remainder of 1. So the answer is the number here, and the remainder is the numerator of the mixed number, and the denominator is the same as the original number. Now, if you just did this in your calculator, you would get, 6.333333, and then you'd have to convert this decimal into a fraction. But it's easier to do it this way, is to see what your remainder is when you do it, and that remainder is your numerator of the fraction part of the mixed number. Okay, so that's all I'm going to say about that. You can practice homework problems. Okay, what time we got? 1:52. So we'll get there. Okay, and I usually give one like this on the test, where you have to use a few of the properties or a few of the techniques for both adding and subtracting and dividing rational numbers. So we have to think about order of operation. You're always going to do the numerator separately and the denominator separately until you can come up with single rational numbers in the numerator and the denominator. So we've got two terms in the numerator and 2 terms in the denominator. So you could do the math separately and then combine it once you've done it, or you can do it all in one, not in one time, but you can keep this thing together. So what I would do is I would replace 2/3 plus 1/6. I'd use the cross multiplication thing. So I'd have 2 times 6 plus 1 times 3 divided by 3 times 6. So that's the formula for adding fractions. If you're subtracting fractions, it's always the numerator here times the denominator is the positive part, and then you subtract the other part, and you divide by 3 times 6, like that. So I haven't done anything. I'm treating this separately and this separately. Now you might say, well, can I cancel that out with that? You could, but don't do it yet. Let's wait till a more appropriate time once we've simplified everything. So we go ahead and do the numerator here, which would be 12 plus 3, which is 15. So I get 15, the denominator, 3 times 6. And then I have 12 minus 3, which is 9. And my denominator is 3 times 6, which is 18. So I've done all the stuff in the numerator here. So I've really got multiple numerators and denominators. But what I've done is I'm doing this operation first. And then to do this part, I have to finish the multiplication here in the top before I do any more, until I get a single number. And then finally at this point, you can say that dividing by a rational number is like multiplying by its reciprocal. And I realized I just wrote the wrong number down. So I get to that point. At that point, you could cancel out the 18s. There, it's very obvious that you have a common factor. So let's just do that, rather than doing it up here, because there's just so many numbers. It's hard to keep them straight. So then you get 15 ninths, and you say, okay, can I simplify it? Well, I can't simplify it using 2, so I go to the next prime number, which is 3, and I can. So I divide by 3, and I get 5/3. So the final answer is 5/3. Okay. So I've usually put one of those on the test, so make sure you can do that. So make sure you write that down in your notes and that you do an appropriate homework problem and you understand it. Oh, by the way, that reminds me. That doesn't remind me, but I was trying to think, is there anything else I need to tell you besides you should have received an email with the review for this class, so I'm encouraging you. It won't take you more than 5 minutes probably to do. Part of the accreditation for the college is that you get feedback on your teaching, which is through student evaluations, and so you have questions that are, you know, probably on a scale 1 to 10 kind of thing, but there's also opportunities to write comments. So I encourage you to write comments about what you don't like, what you do like. I'm not going to get fired for what you say that I don't like, but I would like to know what I need to change. So just think of it as a pretend you're my supervisor and you are trying to give me constructive advice on what I need to do differently. And if you like something that I do, that's nice too. You can put that in there, but please spend the 5 minutes. You just have to click on a link, and it's pretty straightforward. If you don't do it this semester, we'll bug you again next semester to do it. But it does actually get counted, you know, as far as the review. It's kind of funny about reviews. Has anybody ever had a review at where they work? Yeah. You got a raise. Wow. Yeah, that's the thing. We never get raises, so it doesn't really matter a whole heck of a lot. The only time reviews come into play is if you do something they want to fire you for, and then they'll go back and they'll find something to fire you for, you know, just in your review. But they haven't given salary increases for state workers for the last 6 to 7 years, so it's probably not going to. And they usually just give the same amount to everybody, so it doesn't affect pay. My wife's she works for the county schools, and she's like, I've got to have this review, and I said, it really doesn't make any difference because they're not going to give you a raise anyway, and if they give you a raise, you know, you'd have to really be doing something terrible. But she's very conscientious, so she takes it seriously. But it was like Meade Westvaco when I worked there. They did this thing where they were trying to incentivize, you know, give you some incentives to. That's why they give you a raise. You must have done a good job, right? Where did you work? Oh, Tractor Supply. Okay, so they do that. You know, they give you a raise, hopefully to say that you did a good job. So they would give you a goal. They give you goals. Do you have goals? Yeah. So you have goals, which depending upon what your job is, you know, it's supposed to relate to that. So they would give you a goal. If the mill increases production by 2%, you'll get a certain raise. Well, you're one person out of 1,500 people at the mill. Is you individually going to have any effect on the bottom line? Probably not that much. So it was really a goal that had no bearing on your personal performance, but they did it anyway. It was always, you know, it was nice to get a bonus because of that, but it was. Yeah, so that makes sense. If you have a personal sales goal, but as a organization, you know, if like you said, the store got an increase, then you got an increase, and you're like, well, I'm only one out of 50 people, how much am I really going to, am I going to work really hard and everybody else goes off and we don't get anything and I don't get any, so it's kind of they try to make it sound like they are linking pay to performance, but the reality is it's so far away from you as an individual that it doesn't really make any sense. I guess it's kind of like voting in some ways, because you think about it. Your one vote supposedly is so small that it really doesn't make any difference, but you have to convince everybody as a group that it does make a difference, because that's, but if you looked at it really logically, unless it came down to one vote difference, which could happen, but it's not very likely. Yeah, that's right. If everybody thinks that, then you lose elections. So it's kind of an interesting psychological concept. Okay, let's do one more of these since it's going to be on the test. So use the rule for adding fractions together first. But I do read the comments, and if somebody makes a suggestion, I don't just blow you off. I try to, as long as most people give constructive. I think if you try to do a pretty good job, you're not a douchebag or something like that. They'll give you constructive. They're not going to say just to get revenge or something like that. So, and usually, it's kind of interesting because some teachers do not like student evaluations, and so they'll say, "Oh, they really don't matter. It's just a popularity contest." But my response to that is, it's because you didn't get very good reviews, so you want to have an excuse for why you didn't get good reviews. That's one thing. Secondly, is that even if you are, if you gave everybody A's in the class, but they didn't learn anything, they would still give you a bad review. It's not just a popularity contest. People don't want to just get a good grade. They like to get a good grade and learn something. So, okay, so that's what I get from those calculations, if I did that correctly. Let me double check here. 11 times 9 plus 15 times 1. Yep, I made a mistake, didn't I? Because I read my number wrong. I thought it was 13. So it's 114. Let's try this. 11 times 9 plus 15 times 1. 114. 15 times 9. So the moral of the story is there. Check your answers if you have enough time. So we get 9. Okay, so that works out. So then you take the reciprocal of the denominator, and I would look at this and I'd say I can simplify this, but that's because I do a lot of stuff in my head. So let's not assume that. Let's just see what we get. 5,130 divided by 1,215. So we need to simplify that, and I'm going to go ahead and take advantage of the fact that they're both divisible by 5. It's so obvious that I'm not going to ignore it. So I'm going to divide both sides by 5. 5130 divided by 5 is 1026, and 1215 divided by 5 is 243. Now, let's see if I can simplify that further. So this is divisible by 3. 1 plus 2 plus 6 is 9. oh, that's divisible by 3 too. So we can divide by 3. So that's good. 1026 divided by 3 is 342. And 243 divided by 3 is 81. So that's good. Oh, we can still divide by 3 again because 3 plus 4 plus 2 is 9. 8 plus 1 is 9. So divide by 3. We could actually divide by 9 as well, since they're both divisible by 9, or they're both 9. But it doesn't take us too much longer to go to the next step. So we get that. And again, they're both divisible by 3, so we can do that. So 114 divided by 3 is 38, and 27 divided by 3 is 9. And that's the final answer, 28/9. Pardon me? 114 divided by 3 is 38. Yep. Okay. So we got 7 minutes left here. Or is it 2:06? We got 9 minutes left. So I'm going to skip that one. So we want to talk about how to do the decimal representation of rational numbers. I'm just going to say use your calculator. Okay. So we could do the long division. The one interesting thing, and I mentioned this I think in previous class, is that you get two kinds of rational numbers. Ones that have terminating decimals, which means that you have a finite number of non-zero digits. So that's a terminating decimal. And then you have repeating decimals. And the rule is you have a terminating decimal only if the prime factor of the denominator is a 2 or a 5, or both. And if the denominator does not have a prime, it says if you take the denominator without a 2 or 5, then you have a repeating decimal. So let me just demonstrate that, because I've got one more thing I need to cover. So if you take, say, 2/50, so if you look at the, and it says it's the only prime factor of the denominator. So if you take what you have to do is a prime factorization of the denominator. So if I divide by 2, I'll get 25, and I divide by 25 by 5, I'll get that. And so the prime factorization of 50 is 2 times 5 squared. So it says that it's a terminating decimal only if the prime factors of the denominator is a 2 or a 5 or both. Well, it's both. So if I plug that in my calculator, 2 divided by 50, I get 0.04. 0.00000. So that held up. The rule held up. Whereas if I have something like 5, say 70 seconds, okay, 5/77. If I do the prime factorization of 72, so far I've got 2's, but then the final 2 are 3's, so I've got 2 3's. So the prime factorization of 72 is 2 cubed times 3 squared. Well, part of the prime factorization is something other than a 2 or 5, so 3. So if I plug that in my calculator, 5 divided by 72, the answer is 0.06944444444. So I get a repeating decimal. So that's the rule. You do the prime factorization of the denominator, and if it only involves 2's and 5's, then it's a terminating decimal. If it involves something other than 2's and 5's, then it's a repeating decimal. So you'll have a couple of homework problems to try that with. the last thing I want to talk about is converting a decimal to a fraction, because that's on my test. Okay. So we're going to start with just a one-digit decimal. So the way I do it, and I don't know what the book does, but is you multiply by 1, but 1 is going to be either 10 divided by 10, or it's going to be 100 divided by 100, or 1,000 divided by 1,000, depending upon how many digits the original decimal is. So because this is one decimal, I'm going to multiply by 10 divided by 10. And the reason I do that is I want to convert this decimal to a whole number. I use the smallest multiple of 10, which will make this product, the new numerator, to be an integer. So if I multiply 0.6 times 10, I get 6. So now it's an integer, not a decimal anymore. And so that's not the final answer. You always have to simplify it by dividing out common factors. So these are both even, so I divide by 2, so I get 3/5. And that's my answer. Okay, so that's how you do it. You're going to multiply by 10, 100, 1,000. Once you get a rational number, which is, then you're not finished, you have to simplify it. So let me do another one here. So here's a 2-digit one. So we're going to multiply that by 100 divided by 100. So when I do that, the numerator becomes an integer, the smallest integer that I can get. And then I simplify that. So I divide by 2, so I get 36 over 50. I divide by 2 again, which is 18 divided by 25. And then I'm done. And you can always check your answer by plugging it into your calculator. 18 divided by 25, and you should get the original answer, which is 0.72. So I could, the only common fact, this is 5 times 5, this is 3 times 2 times, well, 3 times 3 times 2, so it's not a common factor. So that's a 2-digit number. Here we have a three-digit decimal number, so you multiply by 1,000 divided by 1,000. That converts this into an integer. So it's 254 out of 1,000. And then you have to simplify it, so we'll divide by 2. So that divided by 2 is 127. And this is divisible by 3, but this isn't. This is divisible by 5, but that's not. I think that's it. I don't think there's we could find, we could see if what the factors are, but I don't think it's going to work out. And again, you can check it. 127 divided by 500 is 0.254. So that's basically how you convert from decimal to fraction. Multiply by some multiple of 10, create a rational number, and then simplify the rational number. So now I'm going to assign the homework for this section. And there it is. So that's due Thursday, because you need to have it done because you're taking a test on Thursday. Wednesday, sorry. So we'll see you Wednesday. Sorry I had to go so fast, but I need to get that covered. So if you guys online, if you can log off in the next minute or so, so I know you're paying attention. Make sure you bring your homework next time that you haven't turned in yet, because you are. And as far as homework is concerned, you know, a lot of you are keeping up nicely. There are a few of you who have not kept up very well. So I'll still give you some credit if you turn it in. I'm not going to give you full credit, but you can't just blow off all the homework.